All right, hello guys, hello. Uletho kuhle. Yeah, iletho shem. Ngathanda uzijoyinela nje wena apha kulo mbuso wezi live, ne? Otherwise, you're good, Mos Leto, Mos. You're good with we good with what we've been doing so far, Mos. Yonke into grand. Integers, right? Yonke into, Mos. Rational, irrational numbers, number system, akondithini. No challenges, Mos, ne? No challenges whatsoever, rods. Wena undifotele la homework ndikubhalise yona ndithumele ndiyijonge. Which grade? Depends on the grade that people want in this chat. Let's just check that. What would you like when? The only one who's asked which grade. Which grade do you want? What do you want? What do you want? No, actually, let's just, I came here, I didn't come here for grade 12, I came here for grade 10. So sorry, grade 12, grade 10, please. Any grade 10 learners that are here, let's just check you out, just search out and suss out any grade 10 learners in the live right now. Any grade 10. Please, if you are in grade 10, you're here, please double tap on the screen viciously. Just double tap. I'll know that you're in grade 10 if you just double tap. Maybe you don't want to comment and say grade 10. What is in the baseline test tomorrow? Are you kidding me? I don't know what's in the baseline test tomorrow. Who is this person? Who is this person that's asking about the baseline test? I have no fucking clue what's in the baseline test tomorrow. What grade are you in that you are asking about baseline test? Yeah, me don't. Okay. Seems like we've got a mix. Why don't we just revise some? Then sorry, I'm just stressed. No, don't need to be stressed. Remember, guys, baseline test is a test that's supposed to check what do you know from the previous grade. There's nothing to a baseline. Baseline test is supposed to check what do you know from the previous grade. So you're in grade 10 and you're writing a baseline test. Alright, this person who's saying he's writing a baseline test, tell me this. In the number system, what does this symbol stand for in the number system? This is something that should be known by a grade 9 learner, it should be known by a grade 10 learner, it should be known by a grade 8 learner. This symbol here, what does it stand for in the number system? Natural number. Okay, it's only Leto who knows natural number. Okay, this symbol stands for what exactly in the number system? You need to know what the symbol stands for, right, and what it is. So yes, this symbol means Natural number. Do you know what a natural number is? That is the question. Do you know what a natural number is? Okay, let's first look at the symbols. So this here is natural number. And the question is, do you know what a natural number is? So natural numbers, if I can just use the very same symbol, these are numbers that start from 1 and basically include all other numbers that basically, would appear as you increase by 1. So that's what natural numbers are. Natural numbers, they start from 1, they increase by 1 all the way to infinity, as they would say. Those are what natural numbers are. So they start from 1, or they start at 1, and when they continue in 1 to infinity. That's what the natural numbers are. Okay, a second symbol that is very important to know is this one. Know what is the symbol here. What is this symbol for? What does it stand for? This symbol, NJXT. Who's NJXT? This symbol stands for what type of numbers? The N with a little subscript 0 there at the bottom. Okay, Uleto always knows, right? Kwando kuhle as well. So wow, what is this? Leto kuhle and kwando kuhle. We're having the kuhles knowing what should be known. Now this is sweet. Leto and kwando. Yes, these are whole numbers. What are whole numbers? Whole numbers, guys, are basically numbers that start from 0. They also increase by 1. And as they increase by 1, they basically go all the way to what we refer to as infinity. Okay, so those are whole numbers. Whole numbers start from 0, they increase by 1 to infinity. So this symbol means whole numbers. That symbol means natural numbers. What are natural numbers? Numbers that start from 1. Natural numbers start from 1, increase by 1 to infinity. That's what natural numbers are. Okay, start from 1, increase by 1 to infinity. Whole numbers, there's the symbol for whole numbers, the N with the 0 subscript. That stands for whole numbers. The N without the 0 stands for natural numbers. Natural numbers start from 1, whereas whole numbers start from 0. Okay, guys, we need to know this off by heart. Like, it's something that if you are a maths learner, they start from 0. They increase by 1, this family of numbers, to infinity. Okay, we need to grasp that. Okay, I hope we are together so far. Anyone who does not understand natural numbers, counting numbers start from 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You would never stop. You would die counting. Okay. What about whole numbers? Whole numbers are numbers that start from 0. They increase by what? By 1 to infinity. Whole numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You'd never stop counting. You would die counting. You would never be able to actually stop because there's no end. All right, hence we say infinity. Infinity just means there's no end, endless counting, forever and ever, ongoing, never stopping. Okay, the symbol they use for infinity it's like 8, but 8 is dead. It's not standing up, it's lying down. That's the symbol for infinity. All right. Okay, let's move on. 3. We have this symbol. What do we call this symbol? What does it stand for? What type of numbers have this symbol? Very important. We must know the symbol and we must know what is the number. So the Z symbol is for which numbers? Okay, Letokuhle is saying integers. Letokuhle is even having the Need to get the spelling right as well. Maths English learners. Kanye is saying integers. Okay, so it's Kanye and Letokuhle that are actually participating here. No, it's no problem. Yeah, we need to be good spelling agents as well. We need to be able to spell well. Look at J. J is also saying integers. Just Sugar, integers. Slay is saying integers. Very good, guys. Integers. Integers. What in the world are integers? Okay. Integers are whole numbers, including negative numbers. So whole numbers including negative numbers. In summary, it's like you are saying it's your positive and negative, yeah, Jay, you can, can't you? Positive and negative whole numbers. Yeah, Jay, you think you can read my mind? You think you know my story because you can read my mind? Yes, integers, guys, are whole numbers. Remember, we just explained what whole numbers are. Whole numbers start from 0, they increase by 1 all the way to infinity. Now, when we are explaining integers, we are saying integers are whole numbers, but additionally they include negative numbers. When we were talking about whole numbers alone, we did not talk about negative numbers. When we were talking about natural numbers, we did not talk about negative numbers. When we were talking about natural numbers, all of a sudden when we are talking about integers, we say yes, it's whole numbers, but they also include negative numbers. Does that make sense? So integers are positive and negative whole numbers. I repeat, integers are positive and negative whole numbers. So to just give you a sort of like idea of this family of numbers, you are coming from your most negative numbers, and all of a sudden -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, you see, 4, 5, 6, 7, na, you get the point. So in other words, from the negative numbers, we are increasing and decreasing by 1 throughout this family of numbers. There, from 0 onwards, increasing by 1, we have our whole numbers. But we also include the family of negative numbers. So from negative infinity to positive infinity, we increasing and decreasing by 1. That is our family of integers. So if I say, is 8 an integer? Well, as you count in ones from 0 onwards, do you reach 8? Yes, you do. Is 20 an integer? As you count in ones, do you reach 20? Yes. So all in all, what we are saying is that as we increase and decrease by 1, this is the family of numbers that we actually get exposed to. This family of numbers is what we refer to as what? Integers. So yes, Mafia, this content that I am talking about here is appropriate for a grade 10 learner and a grade 9 learner. And a grade 8 learner can also listen. And a grade 11 learner can also gain something, because it's important for these grades as your foundational knowledge for number systems. So what have we learned about so far? Natural numbers. The symbol is the N with that double line there. Natural numbers start from 1. They go up by 1 all the way to infinity. What about whole numbers? Whole numbers don't start at 1, they start at 0. They go up by 1 to infinity. The symbol is N with your 0 there. Integers, they have the Z symbol. These are whole numbers, which we know start from 0 and increase by 1 to infinity, but they also include negative numbers. So that's why we say in summary, integers are positive and negative whole numbers. So when we look at the family, from negative infinity going up by 1, okay, -7, -6, -5, -4, -3, -2, -1, 0. Where are we coming from? From negative infinity. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, to positive infinity. We are going up by 1. This is the family of integer values. 4. Rational numbers. What are rational numbers? The word rational has as its root word the word ratio. Ratio 3:4, which can also be written as 3/4. Ratio is the comparison between two quantities. So this word ratio, all right, a ratio can be written like this, but it can also be written as a fraction. Are we together, guys? So a rational number is simply this: a number that can be expressed in the form A over B. Now this form A over B, this is a fraction where A meaning the numerator and B meaning the denominator are elements of Z, where A and B, meaning A the numerator, B the denominator, are elements. This symbol here in mathematics is a symbol that is elements. What does it mean? It means are. A and B are, or we say A and B are elements of this symbol. Remember this Z, where did we see it? We saw it here. This Z means integers, and we know what integers are: positive and negative whole numbers. So A and B, the numerator and the denominator, need to be integers. But B, where does B belong? B belongs in the denominator. B cannot, this symbol here, the equal sign with a line that is vertical through it, this here means cannot be equal. This symbol means cannot be equal. So in other words, the denominator b cannot be equal to 0. I repeat, a rational number is a number that can be expressed or written in the form a over b. This is grade 10 and 9, where a, the numerator, b, the denominator, is an element or is an integer. But b, which is in the denominator value, cannot be equal to 0. So in other words, a rational number is a fraction. And in the types of fractions that we have what we know as a proper fraction. A proper fraction has a small number at the top and a big number at the bottom. That is a proper fraction. Example, 2/3. This is a proper fraction. It's like having a very small head and a big body, or a big, you know what I mean, there at the bottom. So basically, this is a proper fraction. A proper fraction is a rational number. Why is a proper fraction a rational number? Because it has an integer at the top and an integer at the bottom, and the denominator is not 0. Proper fractions are rational numbers. Second type of fraction, improper fraction. A what? Improper fraction. An improper fraction has a big number at the top and a small number at the bottom. Those who know me very well, I am like an improper fraction. Those who know me very well, I am like an improper fraction. Why? Because I've got a big head but a very small body. So in other words, improper is like saying 3/2. Big over small. But both the numbers, top and bottom, are integers. That is a improper fraction when there's a big number at the top and a small number at the bottom. The last type of fraction is what we refer to as a mixed number. What is a mixed number? 3/2, which is an improper fraction, can be written as a mixed number. But 2/3, which is proper, cannot be written as a mixed number. So 3/2, how do we write 3/2 as a mixed number? We ask ourselves, 2. How many times does 2 go into 3? Once. Big number there on the side on the left. As 2 goes into 3, does it fit in completely into 3? Does 2 fit in completely into 3? Does 2 fit in completely into 3? No. 2 goes into 3 2 times, but it leaves a remainder which is 1. So we write that remainder there on the numerator for the fraction that we are going to write. Then we say 1 over whatever the denominator was is what the denominator will be. So 1.5 is the mixed number for the improper fraction 3/2. Right. So I repeat again. Rational numbers are numbers that can be expressed in the form a over b, where a the numerator, b the denominator is an integer, but b the denominator cannot be equal to 0. So the types of rational number fractions that apply as these rational numbers are the proper fraction, small number, big number, improper fraction, big number, small number, mixed number, because a mixed number can be converted from a improper fraction. So therefore a mixed number is also rational. Furthermore, rational numbers can be expressed as decimals. Rational numbers can be expressed as decimal numbers. What do we mean by decimal numbers? Take for an example 1. There is the first type of decimal that is rational. We refer to it as a terminating decimal. We refer to it as a what? A terminating decimal. A terminating decimal is a decimal number where after the comma the number stops or ends at a particular decimal place. At a particular decimal place. So I repeat, a terminating decimal is a decimal number where after the comma the number stops or ends at a particular decimal place. Let's give an example. 0.25. This here is a typical number that is written at the second decimal place. Guys, this thing here of saying second decimal place indicates where the decimal has stopped. Look at this. Not comma. Let's count after the comma. How many places? First decimal place, second decimal place, particular. Yes, sorry guys, maybe my writing is too doctor-like. I'm very sorry about that. I was supposed to be a doctor in another life. 0.25. Where did this 5 stop? At the second decimal place. Is there another number after the 5? No. So we say the second decimal place is where 0.25 stopped. Interestingly enough, you can convert 0.25 to be a what, guys? A fraction. 0.25 is 25 over 100 when you express it as a decimal number. How do you convert? You simply move the decimal number to the right until you get an integer. So if you move it once, you get 2.5. You move it twice, you get 25. When you have the integer, you write the integer at the numerator. Then how many times did you move? You moved 1, 2 times. That means how many zeros are you going to write in the denominator? 2, because you moved how many times? 2 times. You place the 1 in front of the 2 zeros, that is 100. 25 over 100 or 25 divided by 100 is equal to 0.25. The terminating decimal has been converted to a fraction simply by moving the decimal to the right however many times until you get an integer, which is 25. How many times did you move to the right? Twice, so that means 2 zeros after the 1. And then you can simplify 25 over 100, you get 1 over 4. 1 over 4 is a rational number, which therefore means that this 0.25, because you could convert it to a fraction which has a numerator that is an integer and a denominator that is an integer, that then means that this is a rational number. Okay, so we say terminating decimals are rational. Terminating decimals are rational numbers. Let's look at another example. 0.7. This decimal number stops at the first decimal place. If it stops, it therefore means we can convert this into a fraction. How? We move the decimal once to the right, we get the number 7. We divide. How many times did you move to the right? Once. So that means 1 0. That will follow 1. So the answer for a fraction of 0.7 is 7 over 10. This is a fraction. There's an integer in the numerator, there's an integer in the denominator, there is no 0 in the denominator. So this means that this is rational. Therefore, it confirms that indeed a terminating decimal is a rational number. The second type of rational number is what we call a recurring. A what? Recurring. A what? Recurring. A what? Recurring decimal. What is a recurring decimal? The word recur means repeat. So what is repeating? The number or the numbers, the pattern of numbers, the pattern of numbers after the comma repeats infinitely, or in other words, forever and ever and ever and ever and ever. I repeat, recurring decimal, the pattern of numbers after the comma repeats infinitely, forever. Infinitely means forever, not stopping. Infinitely means forever. Recurring decimal, the pattern of numbers after the comma repeats infinitely. The pattern of numbers after the comma repeats infinitely. For example, 0.3. Because repeating numbers are so infinite, we use symbolism or symbolic notation to indicate repetition. So if you ever see a number and you see a dot on top of number indicates repeating number. Dot on top of number indicates repeating number. So in this case, this means that this is 0.3333333333333333333 3 3. Oh my goodness. And would we ever be able to stop saying 3 3 3 3 3 3? No. So the dot on the top of the number indicates repeating number. This particular number 3 is the one that is repeating. So we can write it, and obviously we know it's infinite, meaning it's forever. So we just dotify to indicate that we know that there are many other 3s that are coming, and they lived happily ever after for eternity, the 3s. Okay. Or 0.24, they can put a line instead of a dot, a line above particular numbers, also horizontal line above numbers. My beloved Pure Maths grade 10 and 9 learners, and also grade 11, you know, it's important for you to know this as well so that you don't get lost. The horizontal line above digits indicates repetition. Indicates repetition forever. So what is repeating here? This is like saying 0.24, 24, 24, 24, 24, and so that pattern repeats itself infinitely. So what are the two things that denote repetition for recurring decimals? Either you'll have a dot above the number, or you might have a line above the number. That way, your recurring decimal, guys, the pattern of numbers after the comma repeats infinitely forever. That is what a recurring decimal basically behaves like, right? Guys, if you are with me and you are loving what you are seeing, then hopefully you can just look there at the bottom if you are in the position to. The support is appreciated when it comes. If not, you can double tap on my screen, guys, and make sure that we are liking the live. If you want as well, you can share the live with others. Thank you, Nokolomteo. Also, if you haven't, you can follow the live creator. These are the things, guys, that really help when someone is live, especially if the content that they are hearing, they feel like it is doing something to their bones, to their brains, and to their minds. So hopefully we are having a understanding. So rational numbers in essence can either be terminating decimals, like you can see there, 0.25, a decimal will stop, number will stop at a certain decimal place. You can write those as a fraction, which is why we even say they are rational, because we know a rational number can be written as a fraction. Recurring decimals, I've told you, these have pattern of numbers that repeat after the comma. It can be one number that repeats, indicated by a dot above the number that repeats, or it could be multiple digits that repeat. It can be also indicated by the dot or the line. It depends what is the numbers that are repeating. For instance, look at this one, 4,152. You put a dot here, you put a dot there. You leave the middle number undotted. This basically means that this pattern of 152, 4,152, 152, 152, 152, this is a repetition credence of numbers, a pattern of numbers that repeat 152, 152, 152, 152, 152 repeats infinitely credence. So that's important as well. You know what it means when they say recurring decimals for digits whereby the first number after the comma, the last number as well, there are three numbers. Evidently and obviously 152 is the repeating pattern of numbers. Melo, when are you going to do set builder notation? Who is Melo? And who is Melo? Who is Melo? Asking that question. When are you going to do? Yeah. See people that just come here. When are you going to do? Imagine. When are you going to do? Yeah, I think this generation is probably one of the most uncourteous, not so generous. There's just fundamental ways of interacting with other people that really escape this young generation's minds. All right. Yeah. I think if maybe people could get better in that front, they start using words. I remember back in the days they would usually say there are magic words such as please, thank you. I feel like this generation does not know those words. These are words that are absent from this young generation's vocabulary. Also, people don't even take the time. Someone will come here, they've never, ever, not even from a bar of soap, no interaction, no nothing, but they throw things. When are you going to? Who are you? I don't even know you. Right? Let alone just the decency of saying hello, and then the use, like I said, these are words that are absent. This generation doesn't know these words. Young people, you need to step up. The AMA 2K need to also learn the code of courtesy and knowing how to interact, because they are very absent. Anyways, back to what I was explaining. All right. So yes, rational numbers are as such. Okay, they can be expressed as fractions, proper, improper, mixed number, and then as decimal numbers. Terminating decimals, I've shown you, we stop somewhere after the comma. The numbers stop at a particular decimal place. That's what terminating decimals are. Recur means repeat, so there's a repetition of either a single digit or multiple digits after the comma, or it could be later down after a certain decimal place where there has been numbers that didn't repeat, where you will see a repetition of numbers. So a line above those numbers that repeat, or a dot above those numbers that repeat, indicates the repetitious nature of that number. Okay. Right, let's look at, we've looked at rational, now we need to look at irrational. Then I'm going to look at real numbers, and then we are going to conclude with non-real numbers. And I think that should be it for the grade 10s for today. Until next time, where I will continue with the other aspects. All right, because remember guys, this here, what I'm doing now is the basic aspects of what you should be knowing as a grade 10 learner. And I'm going to say this very bluntly right now. If you're a grade 10 learner and you've decided to do pure maths this year at your particular school, my boy, my girl, if you are really serious about making sure that you do well in your mathematics this year, please don't play around. Please, this is not the grade to be playing around, where you are just going to be a nuisance in class, you are going to make noise, you are not going to do homework. You still have the audacity to basically arrive in class. Your homework is not done. It's incomplete. I know some of you are probably burning even the midnight oil as we speak. You've just met this live lesson by mistake. You were busy probably doing other homework like life science or accounting or English, and you've maybe been having back-to-back homework this whole entire day. Well, welcome to grade 10, because that's basically how things tend to be. And if you're feeling a bit of pressure, you know what, dear? There's many people that have gone before you that have been feeling the sort of pressure that you are going through. What that pressure has done to them, depending on how they've been able to cope with it, is it's basically enabled them to become a certain way. Hopefully, you will allow the pressure to refine you and not to destroy you. So, Let's take the whole journey of being people that are doing these gateway subjects, maths and science. Take it a bit seriously. Do not play around. Do not act like that grade 9 you were acting like last year. It's not the time, it's not the place. Give yourself an opportunity to really just, give your best. And do the work, people. All right. The only way you will ensure that what you are being taught in class sticks is when you actually do the work that you are given to do when you are taught, after you are taught. So please do it. What are irrational numbers? Irrational numbers are numbers that cannot be expressed as expressed in the form a over b, where a and b are integers and where b cannot be 0. In other words, the denominator cannot be 0. Hayi, so ngaphambi kokuthi uqhubeke ngicela ubuza if isibalo sikanje 0.101 0.016 1 and 6 are recurring. Yes, what about it? Hayi, so ngaphambi kokuthi uqhubeke ngicela ubuza if isibalo sikanje 0.016 1 and 6 are recurring. What about it? What about that? If 1 and 6 are recurring, so you're saying it's 0.016161616. If 1 and 6 are recurring, then that means that's a recurring decimal, right? So what do you want, King Ukuligan? Was. What do you want? What are you saying? What do you want? You need to share with me. Are you asking me, is that a recurring decimal? Because it is. And if it is a recurring decimal, it means that it can be expressed in the form of a fraction. So basically your question is not that it is a solver kanjani. When you want to know how do I show that 0.161616 is a rational number. In other words, how do I convert 0.01616? Is that what you are asking me, Kuligan? You are asking me to show you how to convert a recurring decimal such as the one that you have given me. How do I convert it into a rational number or show that it is a fraction? Okay, yes, nice, no problem. I'll do that for you, Kuligan. Okay, I see you are number 11, 15, my friend. Which means you have been very busy. I'll do that for you. All right, just give me a chance to explain what an irrational number is, because I've explained what a rational number is. There are those who are still following me as to explaining what an irrational number is. So give me a chance. Let me explain to completion what an irrational number is. Then I'll come back and show you how to do this problem that you have asked me in the comment section. Okay, I'm guessing you are not asking for yourself, Nekuligan, but you are asking for the masses. Is that true? Or are you asking for yourself? Are you the one that is in grade 10? Or are you asking for someone else who is in grade 10? That is my question to you. And maybe the sooner you can answer that, the better. Irrational numbers are numbers that cannot be expressed in the form a over b, where the a and the b are integers, and where the b cannot be 0. So very well put, guys. In other words, irrational number, for instance, we say the square root of 2 is irrational. Now, if you were to write this as a fraction, it is the square root of 2 over 1. What you see very well is that square root of 2 is not an integer. Can you see that? I hope you can see that the numerator is not an integer, but 1 in the denominator is an integer. But because this does not fit the definition of a rational number, then it means this one is irrational. Why? Because it is a number that cannot be expressed in the form of a fraction. This fraction is a specific fraction because it has to have a numerator that is an integer, and it also has to have a denominator that is an integer, and b cannot be 0. What you see here is that the numerator is not an integer, whereas the denominator is. So it can't be that one is and one isn't. In order for this to qualify as a rational number, it has to be that both are integers. In this case, one is an integer, one isn't. So this means that this is irrational. Why? Look at the definition. Are numbers that cannot be expressed in this form, because both the numerator and the denominator must be integers. Is this an integer? No, the numerator isn't. Is this an integer? Yes, the denominator is an integer. Is this rational? No, it is not rational, because though it is a fraction, unfortunately not both the numerator and the denominator are not both integers. It's only one that is. That basically means this is irrational. Are we together? I hope it's clear, guys, this thing. For decimal numbers of irrational numbers, there's only one category. You have non-terminating, and at the same time, this non-terminating is also non-recurring. Non-terminating and non-recurring. What does that mean? Non-terminating means the decimal does not stop. Non-recurring meaning it also does not repeat a pattern. Not stopping, not repeating. That's one specific type of decimal that falls in the category of irrational number. So if you were to take your calculator, for instance, and check the square root of checking what? The square root. The square root of what? The square root of 2. Trying to search for my calculator, guys, so just a second. Just a second. Let's see, where is my messed up calculator? There it is. Let's check the square root of 2. Guys, check this out. The square root of 2, I say square root of 2 equal, you see the square root of 2. You come here, you press ST. What do you see? Look at this. All right. This square root of 2, I said to you, is not rational, but it is irrational. Okay. Remember, with a rational number, it's either there's terminating, there's a place where the decimal stops, or it can be recurring, meaning there's a repetition of numbers after the comma, a pattern. Here you don't see a pattern of repetition, so we can't say the decimal is recurring. 2, there is no stopping. Though you look at after the point, you have 4, 1, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers after the comma, and let me tell you this. Your calculator is unfortunately blocked at the 9th decimal place. If we were to open the calculator and have the 10th, 11th, 12th, infinite numbers or infinite positions of decimal places, you guys would see that there are other numbers after 2 that are not even in the pattern, neither are they the same as the numbers you see here before. Alright, if the calculator was opened and had more decimal spaces that you could see, 10th, 11th, 12th, you would see other numbers. No pattern, so in other words, no repeating pattern, and 2, they don't stop. That's another thing. There is other numbers that are just disordered after these 2 that go on forever and ever, but there is no repetition. So that's why we say these are non-recurring, meaning there's no repetition of a pattern, and non-terminating, meaning they don't stop, because after the 2, that's not the last number. Okay, that is the square root of 2 for you. Okay, so we say that it is irrational. We say it's what? Irrational. Okay. Hey, I hope we are together here, guys. I hope we are together forever, together forever, together forever. Decimal numbers, non-terminating and non-recurring, not stopping, not repeating. So square root of 2 is an irrational number. Okay. In your calculator, there is a symbol that we refer to as, what do we call this symbol, guys? Anyone know? There it is. It's there. That symbol there in yellow. What do we call that symbol? Do you guys know? Pi. Pi. Okay, you guys are spelling pi like you are spelling the pie that we eat. So yes, this symbol means pi. Okay, spelled like that, Pi. It is basically, pi is the ratio between the circumference of the circle and I believe its diameter or radius. Okay. Okay. The ratio between the circumference of the circle and its diameter. I believe it's its diameter. Circumference of the circle and its diameter. Yeah. So that value that you get, okay, if you come to the calculator, I'm going to show you just now. You want to select anything that is yellow. In your calculator, you go and press Shift. Then go down here. You are going to select that yellow, which you see there is what? Pi. You press equal. Pi appears there. You come and press ST. You get 3,141,59,26,54. This here, guys, has other numbers that appear. It's an irrational number. No, non-recurring and non-terminating. That is pi. Okay, if your calculator was open, you're going to see that there's no pattern of repetition and it never stops the numbers. They just go on forever. So we call this a irrational number. Pi is irrational. As a mathematical, you wrote 3,141. That 3,141 that you've written is actually not an irrational number. It's a terminating decimal, which means it's rational. So that means you rounded off. Actually, you didn't even round off, because if you rounded off to the third decimal place, you're supposed to have had 3,142. Nonetheless, that's besides the point. The point is that pi is not rational. It is irrational. Why? Because it has non-recurring and non-terminating decimals. Okay? Okay. Yeah. And the approximations that you used in earlier grades, 3,14 and 22/7, both of these are actually not the exact value of pi. That is why you used this symbol. This is not equal. This symbol here means approximately, and remember, approximately means it's close to this value, or you say it's an estimation or an estimate. Think more specifically. Approximately, the symbol means approximately. So pi is approximately equal to 3,14. It's not 3,14, right? This 3,14 is a terminating decimal and it is rational. Okay, the 3,14. Pi, on the other hand, is not rational. It is irrational. And then lastly, 22/7. This here is rational as well. Remember, why do we say 22/7 is rational? It is because 22/7 is fitting the definition of a rational number, a number that can be expressed in the form of a over b, where a is the numerator is an integer, b, the denominator, is an integer, and b cannot be 0. So this here is rational, right? And when you put 22 over 7 in the calculator, right, let me show you just now. 22 over 7, you get a similar value, nearly similar value to pi, but this 142857143, this entire pattern, these 9 numbers, they repeat themselves every time infinitely. So that is why we say 22 over 7 is not a terminating, it doesn't lead to a terminating decimal, but rather it leads to a recurring. So this entire 9 numbers, they repeat. Okay, so 142857143, 142857143 repeats itself. 142857143, 9 numbers repeat. Multiple digits repeat themselves. So that's why we say 22 over 7 is recurring. It's a recurring decimal. As a rational number expressed as a decimal number, it is actually a recurring decimal. Okay, so that's what I wanted to spell out. Okay, so this is not exactly equal to pi. It is a what? An approximation. It is an estimate. Both 3,14 and 22 over 7 are approximates. They are something close to pi. They are not in and of themselves pi, because pi is an irrational number, unlike 3,14 and 22 over 7, which are both rational, but this 3,14 terminating decimal, the 22 over 7 recurring decimal. Okay, which further hammers in the idea that rational numbers have decimals that are either terminating or they can be recurring. Okay, I think I've explained, guys, rational numbers and irrational numbers for you very well. Okay. Ultimately, you've not been listening. How can you ask me what is the actual fraction of pi when I've told you that pi is irrational? Can an irrational number be expressed in the form of a fraction? No, Asemahle. Can it be expressed in the form of a fraction where the numerator and the denominator are integers? No, Asemahle. So you cannot ask me what is the actual fraction of pi, because I've just explained to you that 22 over 7 is not the actual value of pi. It is an approximation or an estimation. What is something that is if I'm saying it's approximately, it means it is close to, but it is not. You know, it's something that's close to a particular thing, but it is not that thing. An estimate is something that is close to, but it is not that thing. So pi is irrational. It cannot be expressed in the form of a over b, where a and b are integers. All right? Right? There's nothing that is exactly equal, that is rational, that is pi, that is rational, and it is like pi. Because remember, when something is irrational, it cannot be rational. It's either you are irrational or you are rational. You can't be both. We can't be both rational and irrational. Okay? So these are rational estimations of pi. They are not actually pi. But in all lower grades, in grade 7 and 6, you may have used this value to do calculations on other things, maybe in grade 8 as well. But this does not mean that 3,14 is pi. No, 3,14 is an estimation, it's an approximation of pi. And 22 over 7, okay, 3,14 is rational, but it is also a terminating decimal, this one. Okay? Whereas 22 over 7, as I spoke to you, all 9 values after the comma, they actually are the 9 values that recur or repeat. So they repeat over and over again. Okay. So please, guys, I hope you are hearing me. Okay, so irrational numbers cannot be expressed in the form of a over b, where a and b are integers and where b cannot be 0. That's us speaking to what? Irrational numbers. And if you look at the decimal number of an irrational number, what are you expecting? A non-terminating and a non-recurring decimal, all in one. It does not stop, it never repeats the pattern of numbers after the comma. That's how an irrational number behaves. Just like pi, it behaves that way. The square root of 2, it behaves that way when you press SD and see the decimal of it. Okay. Guys, if you are saying you did not learn anything today, then maybe you need to confess that. Pemza boy, let us understand this. The minute we have a fraction and the denominator is 0, what do we say about a fraction where the denominator is 0? What does this actually mean? 6 divided by 0. What is any number divided by 0? Any number divided by 0 is what? What do you know about it? By any number divided by 0 is? You tell me. It's not irrational. Any number divided by 0, guys, we say what about it? It's not 0. Any number divided by 0, Delegi, thank you, it is undefined. A number divided by 0 is undefined. Let me show you something. Here's a calculator. Those who are saying it's 0, let's go. 6 divided by 0 is equal. Look, math error. So any number divided by 0, the math error we must understand means undefined. Any number divided by 0 is undefined. This is different from 0 divided by any number. This is different. In other words, 0 over, let's say 0 over 6. 0 over 6. This is an integer, this is an integer, this is a fraction, the denominator is not 0. Therefore, here we have a rational number. And in actual fact, what's 0 divided by 6? That should give us what, guys? 0 divided by 6 is equal to what? Zero divided by 6 is equal to what? Hey, thank you, White Rose. White Rose, now you are answering right. Remember when I asked you just earlier on, I said, what is 6 divided by 0? You did also answer that it is 0. I hope now you understand. There's a difference, guys. Any number divided by 0 is undefined. But if you have 0 divided by any number, then that is equal to 0 always. Let's see the difference. Any number divided by 0 is undefined. In other words, a fraction that has a 0 denominator is undefined. Undefined. Okay. There is something else, guys, that you need to understand. The concept of non-real. Non-real. Okay. Let me show you what I mean. Square root of negative 4. Sixth root of negative 8. You must notice something. Square root of negative 4. Go to your calculator. Square root negative 4. What do you get? Math error. the square root of a negative number. Okay, remember the square root is an even root. It's even, because when you say square root, you are talking about a root that is even. But the minute you have a negative number, what do you see? The answer, maths error. What does the maths error mean? The maths error, guys, means non-real. No. Pemza, this one does not mean, okay? Maths error, guys, means different things under different situations. So when you have a negative number underneath, a negative number inside, a negative number inside a even root is non-real. A negative number inside a even root is non-real. I repeat, a negative number inside a even root is non-real. So the maths error here does not mean undefined, it means non-real. This is situations where you have a negative number inside a even root. So the square root of -4. This is an even root inside the negative number. When you punch it in your calculator, you get maths error. This maths error does not mean undefined. It means non-real. Non-real. Okay, let's check. Here's another even root. The 6th root of -8. Let's go again. You go to your calculator, you check this guy, this button. So we are going to say shift, choose that button. This is what we get. So we can put the 6 there, because that means 6th root. We go inside, we put the negative number in there, -8. We say equal. Boom. What do you see? Maths error. What does this maths error mean for a negative number inside a even root, grade 10s? A negative number inside a even root. Now I'm going to see if you guys are listening. What does it mean, this maths error? The math error here means something else. It does not mean undefined. It means non-real. Thank you, Pemza. Okay, Pemza, you are listening when? White rows, I don't know what rows when you are under. You know, that rows, they are, my letter. A negative number inside a even root. Pemza, you got it when? A negative number inside a even root is non-real. The maths error that you get means non-real. Please, guys. This maths error is different from the maths error you get when you are taking a number and dividing by 0. A number divided by 0 is undefined. This here is not non-real, it is undefined. A number, any number divided by 0 is undefined. Your calculator will give you maths error, but that maths error does not mean non-real, it means undefined. And you need to differentiate between those two things, guys. If you don't differentiate and you mix these things up, then it means you don't care about your maths for grade 10, Shem. And I'm sorry for you, because it means you are going to really be struggling with other things. Guys, these are basics. These are basics. There's no difference. If it's like not knowing that in maths there are 4 operations: plus, minus, divide, and multiply. The minute you don't know how to use those operations, then you are wasting your time with mathematics, because you are constantly going to be adding, you are constantly going to be subtracting, you are constantly going to be dividing, and you are constantly going to be multiplying. The minute you don't know what those operations mean and what they are used for, then you are wasting your time. In the same way, in your introduction of grade 10 knowledge, you need to know the number system, what a natural number is, the symbols, what a whole number is, the symbols, and the numbers, identifying the numbers, what an integer is, the symbol, the meaning, how to identify rational numbers, the meaning of a rational number, the types of rational numbers that you find, from fractions to decimals, terminating and recurring. You need to know all of these things. Then an irrational number. What is an irrational number? The symbol. All right. Oh, by the way, irrational number, the symbol is an Q with an apostrophe. So whenever you're talking about irrational numbers, the symbol Q with an apostrophe means irrational. Whenever you are talking about rational numbers, the Q alone without an apostrophe means rational. Integers, the Z. Whole numbers, the NO, no. Natural numbers, the N alone. These are the symbols that you need to know. Alright? And you need to know the definitions. When you don't know these basic things in grade 10, you are playing when you are saying in very funny language, you are saying, I don't like this maths, I want to fail it very badly, and I'm not really interested in any career that has to do with maths and science in the next future. And one day I'm going to pass with a bachelor, but this bachelor is not going to lead me to anything. Okay? Alright, now I need to go to that question that someone had. There was a question that someone had about asking, how do I show? What was that decimal? 0.016. So let's say we were given a question like this, and the question says, show that 0.016, where the 1 and the 6 are recurring, are rational. Okanye is rational. And you need to show steps. Okay. So questions like this, what you need to first understand, we are dealing here with a recurring decimal. This is not a terminating decimal. So you cannot just write the answer. You need to show how you can convert this recurring decimal, because by the mere fact that there's a dot on top of 1 and 6, it means the 1 and the 6 repeat. So what you do first, you say let x be equal to the given decimal number, and then you write it out with its repetition like this: 0.0161616, and maybe it would be fine to just do the repetition 3 times. I think it would be good enough, or 4 times. It's really up to you how many times you want to do the repetition. This is equation 1. By doing this, you are actually starting off answering the question in a very good way. Are we together so far? Kulegan, you are the one that asked this question. Pemza boy, what you've written in the comment section is not the way that we answer. But you are going to learn, and hopefully you are all with me, learners, so far. Let x be equal to the given decimal number. You always start there. Let x. We use the variable x. X is very famous in maths. But that doesn't mean if you wanted to, you couldn't use any other letter. Remember, x is just a variable. Okay? Now listen to me now, and listen to me very well. What is the objective of doing this? What is the purpose? The purpose is to establish 2 equations which have the same numbers after the comma. Now, can I tell you something very quickly from just what I can see here? I can see from this that if I had my comma here, you see where the comma is now? If I had my comma here, and then I had for the other equation my comma here, then I have two equations that are actually going to have the same numbers after the comma. Are we together? If I had my comma here, all right, now in order to have my comma to be here, what do I do to the x? And subsequently, if I do that to the x, what can I then do to the left-hand side and the right-hand side of this equation? I can go ahead and multiply by a power of 10. If I multiply by a power of 10, what happens to my comma? It moves one decimal place to the right. So if I multiply by 10, what I do on the left with an equation, I have to do on the right. So multiplying by 10 this side means I move the comma to the right once. So I have not, if I move the comma here, now what do I have? Not comma 1 6, not comma 1 6 1 6 1 6, and it repeats itself like that. That is my equation 2. When I look at these two equations, after the comma, what do you see? 0 1 6. After this comma, what do you see? 1 6. It means after the comma, I don't have the same numbers yet. Remember, what did I say? If I could move my comma here for my one equation and then move my comma there for my other equation, I will have accomplished having two equations. So far, I have my first one. This is the equation 2. It's not comma 1 6. So let's try now and establish a third equation, but this third equation needs to be spot on. Remember, I said if I could have an equation that where I've moved the comma here, which is this one, and then another one, how many times do I need to move additionally? 1, 2 more times. So that means on this, I need to add 2 more zeros. So what can I multiply by to the original equation? Okay, in the original, guys, I need to multiply by what to get here? 1, 2, 3. From here, I need to multiply how many times? 1, 2, 3, so that I can have an equation where the comma has 1 6 1 6. So this is what I'm going to do. I'm going to 1, 2, 3. That means I multiply this x by what? Not by 100. I'm not going to waste my time and multiply by 100. Multiplying by 100 is just going to waste my time. So I'm going to multiply exactly by what I need to have the same numbers as I have the same numbers here after the comma. It's 1 6, that's the same number. So in order to get there, 1, 2, but I'm coming from here, so it's 1, 2, 3. That means 3 zeros. That means I'm going to multiply the x above by 8,000. I'm still looking at the original equation. I'm still looking at the original equation. What do I do to the original equation? I multiply it by what? 1, 2, 3. Means how many zeros? 1, 2, 3. I multiply by 1,000. Then what do I have now? 1, 2, 3. So I have 16, 1 6 1 6 1 6, and that's my equation 3. Now I am very safe. What can I see? I can see this equation after the comma 1 6. This equation after the comma, I also see 1 6. This is very good. Equation 2 and equation 3 are what I need to solve. So I'm going to now subtract big equation minus small equation. Equation 3 minus equation 2. Equation 3 minus equation 2. So I'm going to say 1,000x minus 10x. 1,000x minus 10x on the left is equal on the right 16,1616 minus, I know it's all, minus 0,1616. So on the left, what do I get? 1000x. Sorry, not minus x, minus 10x. Because remember, this is the equation. 3 and 2. So you see now I'm going back here. 3 and 2. These are the two equations. 1000x minus 10x. 1000x minus 10x gives me 990x on the left. On the right side, remember, 16 minus 0. That will give me 16. This 1 minus 1 is 0. 16 minus 6 is 0. 1 minus 1 is 0. 6 minus 6 is 0. 1 minus 1 is 0. 6 minus 6 is 0. That's why we want the numbers to be the same after the comma. That is why we are interested in getting the two equations that have the same numbers after the comma that are the same. Same. Then it allows me to just say 16 minus 0 and get the integer value. Whilst 1 minus 1 is 0, 6 minus 6 is 0, 1 minus 1 is 0, 6 minus 6 is 0, 1 minus 1 is 0, 6 minus 6 is 0. So I get 16,000 and 16,000 is 16. You see? Makes life beautiful. What's the whole point of making sure that the numbers are the same after the comma? Is so that I can have a integer value. Then I solve for x. Divide both sides by 990. X is equal to 16 over 990. And if push comes to shove, I come here, go to my calculator. See, can this be simplified any further? 16 over 990 equal. There it is. And I write my answer simplified, not as this, the final answer, but that as the final answer. So my final answer is 8 over x is equal to 8 over 495. Done. And then I can just verify and check, is this really it? So I come back here, I have that, come press SD here just to check. There it is, guys, it is, it works. It works. It really works. Two equations that have the same numbers after the comma. That is the goal and the objective of the setup at the beginning. Two equations that have the same numbers after the comma. That is the objective of this thing. So if multiplying the first time does not help, you have to multiply by other powers of 10 until you can get the two exact equations that will have the same numbers after the comma. Then when you have gotten that, your subtraction can happen between the two equations. You get an integer coefficient of x. You get an integer value on the right. Then that helps you when you simplify to get the actual fraction where the numerator is an integer, where the denominator is an integer, and where the denominator cannot be 0. This is a true rational number because it can be expressed in the form of A over B. You are welcome, Kulekan. You are welcome, Kulekan. I live for this. You are welcome. All right. You are really welcome. Yeah. Any other questions, guys, that are burning? No, you're welcome. Very welcome. Yeah. I can sense that at least even if your entire generation does not use these words, but at least there are some people who are hope for your generation. You know. I don't know if there's any further questions. Someone I sent you a private. It's only if you follow me back, but I left the boot. I sent you a private message. It says only if you follow me back, but I left the boot. Oh, okay. No, I will definitely get back to Norma. Yeah. Norma Ganja. Alright. Yeah, I don't know if there's any other questions, good people. No? So these are questions that pertain to rational. This is application. Now we are applying this idea of, okay, we now know what the definition of a rational number is. So now we want to check, you know, a recurring decimal. We are claiming that a recurring decimal is rational. Let's show it. And here we go. Okay, guys, if you don't show the steps to do this, then you lose the marks. Yes, Asematla, what's your question? Majola. What's the question? If you have it. Okay. Then also, you guys are also doing these questions, which are supposed to check irrational between which two consecutive integers does a particular number lie. Between which two? Okay. Does a particular rational number lie? Particular irrational. Okay, so let's look at a few, and I'm gonna look at your one as a match. Let's look at 3 of these questions. All right, so that we can better understand. Let's look at these 3. Between which two consecutive integers does the square root of 2 pi and the negative square root of 12? Where do they lie? So let's look at the first one. The question usually says, between which two consecutive integers does the square root of 2 lie? So obviously we know the square root of 2, there it is. Okay. Actually, let's just do this as well, so that we can have some clarity here. So what you do is you write down the number underneath the square root without the square root. Then you need to find, because we are dealing here with the square root, where now you need to find 2 perfect squares. One that you know that is before 2, and another which is after 2. The inequality signs should be like this. So give me 2 what? Perfect square numbers. Guys, what are perfect square numbers? What are perfect square numbers? Perfect square numbers are numbers formed by multiplying a natural number by itself. So by now you should know what a natural number is. Numbers that start at 1 increase by 1 to infinity. So if you multiply the first natural number by itself, you get 1. This here is what we call a perfect square. 1 is a perfect square. The next natural number is 2. If you multiply it by itself, you get 4. 4 is a perfect square now. 3 times 3, the next natural number. If you multiply 3 and 3 by itself, you get 9. This is the perfect square. Guys, you get the point. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. You see? And so it goes. I hope you get the point. Okay, so we need to write a perfect square number that comes before 2 and a perfect square number that comes after 2. So one that comes before 2, a perfect square number that comes before 2 is what, guys? Let me hear you guys tell me what is the perfect square number that comes before. Okay, as I said, the one before 2 is 1. Okay. Okay. And then the one after 2 is 4. And if you go down, 1 and 4. These definitely 2 is in between 1 and 4. These are the perfect square numbers. Okay. Then after that, you put on the square root that you had removed from 2. Remember, this was the square root of 2. Then it means you are going to put on the what? The square root for these perfect square numbers. Then you apply the square root to the 1. You get what? 1. You apply the square root to 4. You get 1? 2. Then that means the square root of 2 is what? Greater than 1, but less than 2. The square root of 2 is greater than 1, but less than 2. I repeat, you read this from the middle to the left to the right. How do we read it? The square root, you don't have to write this down, but I need you guys to understand. The square root of 2 is greater than. Why are we saying the square root of 2 is greater than? It's because the mouth is open towards 2. And this number being here in the middle means this number is bigger than that one. Does that make sense? This number here is bigger than that one, but it is smaller than that one. Does that make sense? So the square root of 2 is greater than 1, but less than 2. Okay, I need you to also grasp how we read this from middle to left to right. Middle to left to right. And take note, they open their mouth to the right, not in opposite direction, to the right, both of them. Please guys, please, otherwise if you mess up these signs and you do funny things, oh, this is the smallest number, 1, and this is the biggest number, so it must always that this is small, this is big. Please guys, don't butcher this, I beg you. Right? So then you can conclude, therefore, the square root of 2 lies between 1 and 2. 1 comes immediately before 2, and the difference is 1. I mean, that's how it should be. The difference between these two consecutive integers should be 1. Let's look at the next one. What about pi? Pi. With this one, guys, we simply come to the calculator. You go and press pi. Okay, shift. Remember we said when you want to pi, press shift. For the yellow buttons, we press pi. Pi, we say equal. We press SD. The number is 3,14. Right? So in our heads now, it gives us an idea. Okay, so this number is between what? If this is 3,14 is a decimal number, then it means that we have 3 here and we have 4 there. It's as simple as that. Okay, already here you have 3,14. So what is the number that's here? It's 3, guys. What's the number that's there? It's 4. Okay, here I'm not talking about perfect square numbers because pi, there is no square root. All right, it's simply pi. So it's a matter of going and checking from my calculator, what is the value of pi as per its what? Decimal. I get it, 3,14. What are the two numbers that pi lies in between, which are consecutive? So remember, if this is 3,1 something, then before that number, the integer that was there is 3. and after that number, the integer that is there is 4. It's as simple as that, guys. Don't complicate life. 3 is then followed by this number, which is 4. The difference of 3 and 4 is 1. We can't have a difference that's greater than 1, guys. It has to be 3 and 4. Therefore, you can conclude, therefore, pi lies between 3 and 4. Don't complicate life. It's straightforward, this thing. Alright? Please, man. Please. Okay? Alright. I don't know if there's any questions. Okay? No questions? Any questions at all? Yeah. Why didn't we choose the perfect square? Because we don't have a root. And it's not a square root. The only time we choose a perfect square number is when we have a square root. So we use perfect square to choose. And then we apply the square root. Then we get the values. But here we have pi. What root do you want to apply? No, guys, please don't complicate life here. Okay? Go to your calculator. We check. Oh, it's 3,14. That means there's an integer before 3,14. Remember, this is a decimal number. What is that integer? It's 3. 3 alone, all right, is immediately before pi. Then 4 comes immediately after pi. So these are 2 consecutive integers, 3 and 4. Okay. Don't know if people are even hearing here. I see the numbers dwindling. That's all I can see. But I can't see if people really are like, okay, I understand. We are good. Thank you, sir. Or not, you see. Moments like this, I just want to stop because I can see no one is here. So, what about the negative square root of 12? Negative square root of 12. Okay. Now we have a negative number. Okay. Negative square root of 12. How do we navigate that one? Okay. So what you should be aware of is that, oh, this one is a negative number. Okay? That's what should dawn in your head. Oh, this one is a what? It's a negative number. Okay? Yeah, it's a negative number. So the first thing you do, okay, the very first thing you do, because you can see, oh, it's a negative number as well. It's a negative number as well. Okay? You can go ahead and write down 12. Because it's a square root, it means that you are going to look for perfect square numbers. Okay, perfect square numbers. But let's be careful again this time round, as we are looking for what? For perfect square numbers. Personally, I would just advise that go ahead and write down the perfect square numbers. All right. I would go ahead and actually put on the negative. Then think about the perfect square numbers. All right. And remember, for negative numbers, it's a different story. All right. Because remember, for instance, for negative numbers, negative 8 will be this side, whereas negative 8 will be followed by negative 7. Negative 12 will be followed by negative 11. You know, it's like a different story for those numbers. Okay. So if we are thinking immediately about that one, perfect square number 16 this side, perfect square number 9 this side, then we put on their negatives for the square root, which is very important. What is the square root of 16? It's 4, but it's negative. All right. Okay, remember what you are putting on is a negative square root, so you only put it on after. And then this is the negative square root of 12, whereas this is the negative 3. And remember, negative 4 comes before negative 3. This is very small. This one is bigger. It's bigger than this. Okay? Hence, you must be careful when you are dealing with the negatives. Then you can conclude, therefore, the negative square root of 12 lies between, and it's true, negative 4 and negative 3 in that order. Okay, so let's be careful there. Okay, we are still, because of the square root, are going to look for perfect square numbers that lie on either side. But because we have a negative number, let's make sure that we write the big number on this side, the small number on this side, because when we put on the square root that is negative, this stops being the big number as per negatives. It becomes a small number than this one. So we need to be careful when there's a negative sign outside our root, that we make sure we write the big number on the side, the small number, because when we put on the root that is negative, this becomes small and this one becomes big. Okay, and look at the difference between -4 and -3. It's 1, because that's how it should be with consecutive integers. Right, let me do this last one, the cube root of 45. Cube root of 45. Now you see, now we are talking about cube. So this time round, we are going to look not for perfect squares, but we are going to look for perfect cube. Does that make sense? 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So already when you look at this, you like the cube root of 45. So these two follow each other. So what are we gonna say? 45, 27, 64. These are not perfect squares, they are perfect. Because we've got a cube root, we need to look now for what? Perfect cubes. Perfect cubes. Okay. Yeah. Then let them put on their cube masks. When you apply the cube root to 27, you get 3. Cube root of 45 is still intact. You get 4 this side. And then what do we say? Therefore, the cube root of 45 lies between 3 and 4. And that's that. Okay. All right. I think I've really zammed you guys. I have zammed you. Okay. Yeah. I think tomorrow what we'll do, or let me say, whenever you do find me go live again, I think this time around I'm gonna try and encourage people to actually, because I see, like, I literally have been live, but people have been very quiet. Yeah, very quiet. It's like so quiet, it's very scary. It's almost as if I'm not here with people. Anyways, so I guess I'll see you again on another, like, maybe just very quickly, let me just round it off with this. Interesting that people, when we're talking about rounding off numbers, if the question here is saying round off this number to 2 decimal places, then you will be shocked. People don't know how to round off. Guys, tell me, comment section, come on. If I'm saying round off this number to 2 decimal places, okay, what is the answer? Let's see in the comment section. Let's see if we have people. 4,31437. What is this if you round it off to 2 decimal places? What's the answer? Yeah, you see, this is exactly what I mean. Who the TF? Who TF is Sims? Kidding me? So it's not exactly what I mean. So whenever you're rounding off, if it says 2 decimal place, you count 1, 2. You put a line here. Then the 4 is the one that asks a question to the previous number. If the 4 is a number, if this number is a number that is 4 and less, then the 1 will what? Stay the same. But if this number was 5 and more, then it would change this number, it would go up by 1. Okay. Let's look at another one, 1,7777, and the question says round off to what? 3 decimal places. So if it is 4 and more, 4 and less, we stay the same previous number. Okay, but if the number is 5 and more, we'll go up by 1. This is the deal with rounding off. So here, 3 decimal places, guys. What would be the answer? 1,7777, 3 decimal places. 3 decimal places. Please write down your answer in the comment section. 3 decimal places. Round off to 3 decimal places. Okay, the F. The fudge. Okay, 3 decimal places. So let's go, guys. Let's see. 3 decimal places means 1, 2, 3. We cut off after 3. The number before asks the number after. Remember, 1, 2, 3. We cut off at 3. This number asks, what do we do to him based on us? This number is a number that's 5 and more. So that means the number before, where we ending it, which is the 3rd decimal place, 1,77. This number is 5 or more. It goes up by 1. We add 1. So that is 1,778. Okay, very good to those that actually are doing the things that they should be doing. Let's look at this one. 365,153,4. The question says round off to 1 decimal place. What would it be? 1 decimal place. Okay, people are starting to wake up a little bit, not sleeping anymore. Okay, very good. 365. We cut off at the first decimal place. The 5 asks, what do we do to the 1? Go up by 1. Okay, 2 decimal places, 594,2. Round off to 2 decimal places, 594,2. .4, round off to 2 decimal places. Okay, very good, guys. Here we are at 1 decimal place. So obviously that means we can't exactly say we are cutting off because we are at 1 decimal place, but rather if we move another additional decimal place, it would be 594,20. Very good. Love it, guys. Very good. Okay, now we have a 0 at the second decimal place, and obviously it would be a 0, right? Very good. The last one. Two decimal places. Two decimal places. Two decimal places. Okay, Masi, let's go. Two decimal places. 1, 2. We cut off here, right? This number says what to 9? We go up by 1. What does that mean, guys? To go up by 1, you add 1 to 9. What happens when you add 1 to 9? What's 9 plus 1? 0. 1 plus 9 is 10. You carry 1. 1 plus 9 is 10. You carry 1. 1 plus 9 is 10, comma. So what's the answer? There it is. Okay. So if I look in the comment section, was there anyone that actually rounded off to two decimal places? 100% correct. The closest was who, the TF. But even he did not actually write down the 2 zeros to indicate that it's two decimal places. So the answer is 10,000. Please, guys, remember that what did we say? What does the 8 say to the 9? Go up by 1. What does go up by 1 mean? It means you add 1 to 9. But remember, if you add 1 to 9, 10 plus 1, 10 plus 1, 10. So it's 10,000. Be careful. Okay, some of you are really struggling with something as basic as rounding off, and if you are going to struggle with other things that are simple. Guys, I don't have time for people that struggle with simple things. You can't be in grade 10 and be struggling with things like this. You should become a master of these things. Okay, feel like I've explained the most. Now we are good, right? Are we good? Can I get an amen? Are we good? And get a rose. 2026, are we good? Okay, people are sleeping. Alright, guys, thank you so much. It was good. I won't be seeing you tomorrow morning, so yeah, thank you, and thank you again for joining. Hopefully this was really helpful. I'll be saving this, I'll download it, I'll be uploading this live lesson that we did, obviously, where I always upload all live lessons that I cover here on this platform. So thank you and good night. Hopefully that was really helpful. You gained something. You're welcome, Sims. You're welcome, White Rose. Yeah, you're welcome, guys.